So a lot of this video is a repeat or a review. So I just want to go through a couple of examples first, and then we'll get into more of the fundamental theorem of algebra. So yesterday in class, we were solving polynomials, and we were listing all the possible solutions, rational solutions, and we were just guessing and checking. That was Thursday. Friday, I actually let you get a calculator and do exactly what this example is. Graph this and find one solution. I see a solution here at -3. I'm going to use that -3 to synthetically divide into the polynomial, and I get this. I know that since that was a cube, that this now becomes a squared and turns into this quadratic, which will factor. This guy comes down as a factor, and then this is the factorization of this trinomial. So I have a solution at -3, 4, and 4. Again, 4 is a repeated solution. It's called a double root, and that means I have 3 total solutions. 4 would have a multiplicity of 2. Here's another example. So in this example, we have a different cubic function, and when graphed it looks like this, and it obviously has a solution at 1. I know from the polynomial that I should have 3 solutions, but I only see it cross once, so let's see what happens. We're going to synthetically divide by that solution and end up with this quadratic. 1 x squared, don't have an x, plus 16. So then I factor this out. I know this gives me a solution of 1, and this gives me 2 solutions at plus or minus 4i. How did that happen? Let's remember again that I'm going to take this factor, set it equal to 0, solve. When I take a square root of this, I know that x is going to be plus or minus. The negative comes out as an I, and the square root of 16 is 4. That's where those other two come. That would give me a total of 3 solutions. 1 plus 4i minus 4i. Again, review. How many solutions does this polynomial have? Well, remember, it has to be in standard form, so I need to look for the highest degree, which would be 5. My leading coefficient would be -6, but the 5 tells me it is a 5th degree, so I have 5 solutions. Let's find all the zeros of this 5th degree polynomial. I know there are going to be 5 solutions. So again, I'm going to put this in y equals and get a graph, and I see that I have a bounce at -1 and a solution at 2. So I'm going to synthetically divide by 2. And when I synthetically divide by 2, I end up with this polynomial. And again, if I start with a 5th, this is now a 4th as indicated over here. But I also see that it bounces at -1. So I'm going to also synthetically divide by -1 and end up with this polynomial. So now the 2 has its own factor, the -1 has its own factor, and this is a cubic leftover factor. But since I have a bounce, I know that that has to have another solution right there. So I'm going to synthetically divide by -1 again, come down to a quadratic. When I come down to this quadratic, I now have factored the 2, the -1, the -1 again, so that would have a multiplicity of 2, and I have this quadratic left. So to complete the solving, I need to take this last trinomial, quadratic trinomial, and I need to either factor it, which it won't do, or use quadratic formula, which is right here. And quadratic formula, as you can see, leaves me to 2 more solutions, 2 plus I root 3 and 2 minus I root 3. So 2 plus I root 3 and 2 minus I root 3. Therefore, I would have 5, 1, 2, 3, 4, 5. Multiplicity 1, multiplicity of 2, and then these are two separate solutions. Here is where the new stuff will come in. Now we're going to write equations of polynomials given that it has the leading coefficient of 1. All of these that we're doing today will have a leading coefficient of 1. Okay, the first thing you have to understand that when I use the quadratic formula, the only way I can get a square root answer, an irrational number or an imaginary number, is if they are conjugates. Remember, it's the opposite of b plus or minus the square root of these things. So these always come in conjugates. So I want to write a polynomial of least degree with a leading coefficient of 1 and 2 plus radical 3 are zeros. So what are our zeros? Our zeros are 2 plus the square root of 3, but I know an irrational always comes with a conjugate. So now these are factors, and if you remember, I want to write the polynomial, okay? So I can't just put them in factors, I need to multiply it all out. So I'm going to put the 2 into a factor with x minus 2. I'm going to put the 2 plus radical 3 into a factor of x minus 2 plus radical 3. And I'm going to put the other one into x minus 2 minus radical 3. And I'm going to multiply all of this out. But first I'm going to do a little math that we know. We have x minus 2. This is going to give me x minus 2 minus radical 3. And this is going to give me x minus 2 plus radical 3. And I'm going to show you something here. I'm going to put some parentheses around the x minus 2. Because remember, based on properties of algebra, I can parenthesis and do this in any order that I want. So I have a binomial minus radical 3, and I have a binomial plus radical 3. What have I created? I have created conjugates. These are conjugates. And we know when we're multiplying conjugates, x plus 2 and x minus 2, I really don't have to, I only have to multiply the first and the last, because the outside and the inside will cancel each other out. That is the definition of a conjugate. So in these complicated conjugates, I really only have to multiply the first and the last. So I'm going to multiply the conjugates first. And when I multiply the first times the first, x minus 2 times x minus 2, I'm going to get x squared minus 4x plus 4. And when I multiply the last times the last, I'm going to get negative square root of 9. Remember, if I multiply the square root of 3 times the square root of 3, I get 3. So I get minus 9. Not 9. I get 3. This turns into x squared minus 4x plus 1. And now I'm going to multiply this polynomial out. When I multiply these two polynomials out, I will end up with this function. If I wanted to check this, I could put this function into my calculator, make sure that it crossed through 2 plus the square root of 3, and 2 minus the square root of 3. Remember, I can bring these to decimal equivalents by putting that in my calculator. If I put these in my calculator, 2 plus the square root of 3 is going to be 3.3732, and 2 minus the square root of 3 will be 0.268, and I can calculate the zeros on my calculator to make sure that this polynomial goes through these two and the 2. Let's do one more of those. So, we want to write a polynomial of least degree with a leading coefficient of 1. 5 and I are zeros. This one's much easier. 5 is a 0, I is a 0, but remember the only way to get an imaginary solution is with a plus or minus the discriminant. So I will always have a discriminant. So I have to add this particular solution into this. Okay, now we're going to put them into factors. X minus 5, x minus I, and x minus negative I. I know that multiplying conjugates is the easiest, so I'm going to multiply them first. X minus 5. I have to multiply the firsts and the lasts. I remember that I squared is negative 1. So this is going to be x plus 5 times x squared plus 1. I'm going to multiply it out, x cubed plus 5x squared plus x plus 5 equals f of x. I always need to make sure that I include the equals f of x because I'm writing a polynomial equation, not an expression. And if I were to put this in the calculator, it should cross through 5 and nowhere else, because remember, imaginary solutions do not cross the x-axis. The only solutions that cross the x-axis are real solutions. See you on Monday.